We're going to look at the third case of permutation. So you remember the first case was if we're going to arrange all the objects, then it was just n factorial. If we were going to arrange some of the objects, then we came up with this new notation of npk. But that assumed all the objects were different. Now, if some of the objects are the same, what happens? Right, so now some of the objects are going to be the same. I guess the way of working out the pattern is to break it down into a very simple case. If I have two objects and they're different, clearly there's two ways I can arrange it. I could go AB or I could go BA. And as we saw, that's 2 factorial because I'm arranging all of them. Oh yes, that is equal to 2. But if they were the same, how many ways? Well, there's only one. I'll go AA. So I guess the question is, how did I get from 2 to 1? Well, how could you turn 2 into 1? Divide by 2? What's another way you could get from 2 to 1? Take away 1, thank you. So the question, well, which one is it? Let's investigate further. All right, we have 3 objects. Now, if they're all different, there we go, ABC, ACB, BAC, BCA, CAB, CBA. Sure enough, 3 factorial, or 6 ways. Now, to get to 2 to the same, if it's subtract 1, then we'd be expecting 5 as the answer. If it's divide by 2, we'd expect 3 as the answer. Well, let's see. If 2 of them are the same, and there we go, it is actually 3. So we can go AAB, ABA, or the sheep. Bah. Well, okay then. What if 3 are the same? Oh, well, clearly, there's now 1. So now I'm going to ask you this question. How did I get from 3 to 1? Because clearly I didn't divide by 2. Divide by 3, thank you. Let's take it a step further. 4 objects, watch out because this will take a bit of space, all different. There they are. There are 24, or 4 factorial, possible ways. Now, if 2 are the same, we're saying, oh, divide by 2. Let's see what happens. Whoop, sure enough, there are 12. 3 are the same. What was it? We divide by 3, was it? Now, do we divide was it the 12 by the 3 or the 24 by the 3? 24. Okay. So yes, we're expecting 4. So yes, we divided by 12 by 3, but more importantly, we actually divided the 24 by 6. 2 times 3. And of course, 4 the same is 1. So to get to 1, I'm actually dividing 24 by 24. What's the significance of that? Because what has happened is this. You have divided by the number of ways you could have arranged those objects. But because they're the same, you now don't have that many ways of arranging them. So you divide by that many arrangements. So if you've got n objects, but of which x of them are the same, the number of ways you could arrange them would be n factorial, the ways of arranging all of them if they were different, divided by x factorial, the number of ways you could have arranged the same objects if they were different. So let's look at some questions. Connaughton, a student I taught many, many years ago now, but I always use this as an example because I think it's a wonderful name. Look at all those different letters and same letters and great one. So how many different words, using all the letters of course, can be formed from Connaughton? Well, there are 11 letters in Connaughton, and in those 11 letters we have 2 O's, so 2 factorial, divided by the number of ways the O's could have been arranged if they were different letters. And there are 3 N's, so we'll divide by 3 factorial, the number of ways we could have arranged the N's if they were different. So we end up with, and what do we get? There we go. Wow. Take you a while to write all those words out. Here's an HSC one. Now, of course, in the HSC, they explain everything. They can make no assumptions. The letters A, E, I, O, and U are things we call vowels. Okay, just in case. How many arrangements of the letters in the word algebraic are possible? And they are meaning using all of them because it's arrangements of the letters, so of all the letters. Well, algebraic has 9 letters in it, and now we're looking for repetitions. There are 2 A's, but that's it, isn't it? So there we go. 9 factorial divided by 2 factorial, the number of ways we could have arranged the A's if they were different letters. How many arrangements are possible if the vowels, hence why they defined what vowels were, must occupy the 2nd, the 3rd, the 5th, and the 8th positions? So the vowels must go into 4 positions, and luckily for us, the word algebraic has 4 vowels. That worked out nice. So we're going to use all of the vowels. So basically, we're going to say, how many ways can we arrange all of the vowels? There are 4 of them, therefore we can arrange them 4 factorial, but some of those vowels are the same, so we will divide it by 2 factorial. Okay, so that's our vowels are now placed. And they've worked out the order, and we've slotted them in the 2nd, the 3rd, the 5th, and the 8th position. Well, now we have to organise, I'm going to use a fancy word here, the consonants. Yes, consonants, they're the other letters. Times, now we're going to arrange the consonants. 5 factorial. So the number of ways of arranging. So we end up with 1,440 ways of doing that. There we go. So just a quick one today, just adding in this extra idea about, hey, what happens if some of the objects are the same?